Hello, our HazChat friends and family. Welcome to another episode of HazChat. I'm Bob Nano with my conspirator and chemistry unknowns. another
Bob, you are the yang to my yin.
another crazy saying.
And
Oh,
I'm saying that backwards intentionally to drive those of you with OCD up the wall.
send,
The,
send him over
the
a
yang to
cliff.
my yin.
Send, send him over a cliff. Oh, good God Almighty, that's funny. Sometimes I just can't help myself. I got many, many more. I think I got enough of these little openers for the rest of the year. I'm pretty sure. But anyway,
You could you could publish a book.
ooh, more on that later. Anyway, welcome back.
HazChat coffee table book.
Oh, you know what?
Look for that one for Christmas 2026, friends.
Dude. We could totally do something. All right, we'll talk offline. I don't want to give any ideas and steal our stuff because that
Mhm.
never happens. All right, so here we go. Um, you got me going now. We're gonna talk about this is kind of, we want to make sure everybody understands something when we're talking about um, what really happens on hazmat calls, and people jump around from PowerPoints, how the PowerPoint says it should go, and whatever. Today we're gonna step on sacred ground, maybe with meters. I don't know.
Well, we both teach meters. We're not here to bash meters. Meters have their lane, and it's as much as Bob and I push, use your meters, take them out, do these things. There's also times where we need to think beyond the meter. We have to start at the beginning. The meter is not necessarily the beginning. It's not necessarily the end. It's usually somewhere in the middle. So we're gonna take a step back from meters, and we're going to talk about something a little different.
And we're gonna do that right after a message from our sponsors. Hey, HazChat listeners, looking to boost your skills? Check out respondertraining.com. They've got top-notch responder training and essential tools like their 1-inch propane and CNG flare-off kits, water injection tools, and much more. Train smart, stay safe, and excel in the field. That's respondertraining.com. Enhance your hazmat training with Signal, the most realistic gas detection training on the market. For under $100, you can simulate any detection combination from handheld meters to fixed location monitors, and even confined space scenarios with their universal pump attachment. Signal delivers unlimited range and detector combinations trusted by top teams around the world. Visit signalapp.com or download the app now. Signal, unlimited range, unlimited possibilities. In Our Gear products, built by first responders for first responders. In Our Gear delivers innovative, field-tested tools for every level of hazmat response. The ZMAT card empowers ops-level responders to set the initial tone with quick, easy-to-use hazard identification. The ArcLaw line boosts efficiency for technicians in the hot zone, and the WIMS board enhances command competence from behind the steering wheel. Trust in Our Gear, where reliability meets response. InOurGear.net. And here we are, back like movie magic, as we always say. Love it. So when we talk about the PID says 0, multi-gas is clean, no alarms, so everybody relaxes, right? And then 10 minutes later, somebody's dizzy and someone's nauseous, or, now we're scrambling backwards, asking questions. Oh, what should we ask up front? What are we going to do? What are we actually dealing with? Crazy.
Yeah, and that's when we get to the whole thing. Well, the meter didn't show anything. I I had no change from baseline, and it didn't show anything. Well, the meter did show something. It
Yeah.
didn't show the something that you wanted, but it showed you that the things it's looking for were not at detectable levels, or something was interfering with it, or there's a maintenance issue, whether it's electrical or chemical issue. But there's a difference between it didn't show me anything and it didn't show me the something that I wanted it to.
Right. But I think we're along the way, the fire service started treating meters like answers instead of tools. And when that happens, chemistry gets ignored and people get hurt. So
Yeah, and I mean we get to that point where people start, they're listening for alarms, they're listening for beeps. And if it didn't alarm, everything must be good. Oh, we're fine. But that's how things go bad and careers can end. Whether it's through missing something or unfortunately having a tragic event. Like, so we want to make sure that people are looking at it from the broader view of detection.
right, and meters don't detect danger. Let me try again. They detect parameters. A PID detects, ionizable. I can't talk this morning.
Ionizable.
Thank you. Good God, I need some more coffee.
It's a difficult word. It's a difficult word.
Yeah, compounds above a certain energy level. Oh, this is going to be a good show. A forecast detects exactly what it's designed to detect, and nothing else. So if you have a 4-gas meter that's there to detect, and I'm going to say this just to see if I can trap anybody: O2, LEL, CO, and H2S. Wait, Derek, does an O2 sensor detect oxygen?
No, it does not.
Ooh, and don't say what it does. Drop a comment in the episode. You tell us what the O2 sensor detects. See if anybody is really paying attention out there in HazChat land.
Yeah, and real quick, let's jump into one of the misunderstandings is about calibration. And it's, I calibrated my meter and it responded to these gases. So I know that it's going to be good for these gases. Your meter responded correctly and in a anticipated manner to pure product under the conditions under which you calibrated it, which was no interferent gases, no humidity shifts, temperature shifts, those things. It was very controlled. So, yes, calibration makes our meters as accurate as possible. But we have to remember that when we're not hooked to a cal gas bottle, the gases that our meters are seeing are not in pure states. They're not in dry states. They're in the conditions of the actual environment that we're in. So there will be a difference in response to some extent.
Yeah, and no alarm does not mean there isn't any. There's not harm, right? Like if and it's like when we talked about in the meter class, your sensors, and we already talked about dead banding and all that in previous episodes. If you haven't heard that, go back and check the episode we did with Chris Holley when we mentioned all that. But it's almost like your tachometer in your car. You got to push that pedal so far before that needle starts rising, and that's the thing with your meters. And so just because it's not alarming doesn't mean there's not a hazard.
Yeah, and all of our detection equipment can quote unquote lie to us. It's the devices and the papers and everything else do not have malicious intent. It's just an operational limitation. They are fantastic for the environments that they were designed for and the challenges that they were calibrated for. When we take them into the real world behaves a little bit differently. And we have to understand that that's going to drive some of those limits. And we have to look beyond just what the meter's saying.
Right, because PIDs have blind spots, low vapor pressure chemicals, high humidity, suppressing readings. Because, wait a minute, we don't have any high humidity here in FLA, do we? Oh, yeah, we do.
Not right now, we don't.
Because no, not
it's
right
like
now.
37 degrees outside, and it's basically snowpocalypse in Central Florida right now.
And I want to say this is going to be one of the February episodes. And we want to thank everybody up north for sending us your cold, lovely weather. The iguanas have dropped out of the trees, but I digress. So anyway, the other things are oxidizers throwing interference, mixed atmospheres, confusing sensors, cats chasing dogs. It's mayhem.
Yeah. Well, and one of the things you have to think about too is is shielding. And when we talk about shielding, we're not talking about like we've put a dome over top of it and we've shielded it off. It's just changes in how that product is going to get to our devices. So right now is a perfect example. While you friends up north are used to these temperatures, we're not, which also means we're not used to doing detection in these temperatures.
Very true.
So things that previously in our normal summertime weather are readily vaporizing and producing detectable vapors, once we start reducing the temperature, we're going to have different responses. We're going to have less vaporization. Our sensors are going to take more time to react because we're going to be getting into chemistry. We're going to talk about chemistry in this. And a lot of times we forget our meters are chemistry.
Right.
Those electrochemical sensors are little tiny chemistry experiments. And that experiment is going to happen at a slower rate when the temperature drops. So for our southern listeners here in Florida, something that we don't think about a lot, we have to acknowledge that this is a different approach for us, whether it's our multi-gas meters, our PIDs, all those things are going to be affected because vaporization changes, the chemical reactions change, and it will even affect our papers because everything is driven by heat. Heat is what makes chemistry work.
Yeah, and if your entire hazard analysis lives on a screen, you're not doing analysis. You're guessing with confidence.
Yeah. Yeah. And, sometimes wet chemistry gets kind of brushed off as being like old school. Now, there's a wide spectrum of wet chemistry, something as simple as a few colorimetric papers to a full blown out wet chemistry kit, HazCat kit, phenomenal kit, big learning curve for new technicians. But there's stuff in between. There's tests that you can do in between. And that's where Bob and I tend to focus when we teach is what can the average technician with limited capability understand chemistry wise.
Right. And what chemistry isn't about naming a chemical, it's about classifying it. And that's all we're trying to do. It's just if I could put it into a box or something like that, which we'll talk more about later, then I got a pretty good idea what I'm dealing with. And now I can set my tactical decision making off of the classification that we made.
And that's one of the things I think we get into with all of our different technologies, with like Raman, FTIR, and our high pressure mass spectroscopy. Like we like to find answers. We want to know the answer. And finding the hazard class is still an answer. We don't have to have specific chemical. We want to know, is it corrosive? Is it an oxidizer? Is it flammable? Could it be a reducing agent? All those are the things that we want to know. And that is an answer because in reality, those things behave as a certain cluster of hazards. So that's what we're really looking at.
Right. And reactions tell you behavior, color change, evanescence, heat, solubility, reactivity, all these different things help guide you into that classification of what it is you're dealing with.
Yeah. And it's not like, Derek and Bob, they're the old guys and they learned the old way and they're taking us down memory lane and hitting us with chemistry nostalgia. That's just the world that we live in. That's field science. And the great thing is as all this technology's changed, chemistry doesn't change. And chemistry is the driver behind all the things we do. So while I am not an advocate of shoving 80 hours of NFA chemistry down a brand new technician's throat, every technician needs to understand basics of chemistry, chemical properties, physical properties, and then throughout your career, expand on it and get to that 80-hour NFA chemistry class because those things are going to make you a better technician.
Right. And the chemistry aspect directly affects operations, how we're going to go and, different things that we're going to do, where, and so forth.
Yeah. I mean, chemistry drives everything. It's what PPE are we wearing? What detection devices are we going to use? what are our zones? Because depending on the state of matter and how it vaporizes, how it moves, those are all good things. And then decon, like what is the appropriate decon for this product?
Right.
Um, Wet decon, dry decon, hybrid decon. Do I just need to stand in front of a fan? Like all sorts of things. The chemistry is what drives that.
Right. And command doesn't need to know the chemical formula. Command just needs to know the risk clarity.
Yeah. And that's what chemistry sampling, that's going to give you those decision makers. It's going to say, this is where we're going, and it's giving you something a little bit more tangible than just numbers, because we're actually seeing a response. We're seeing a reaction where with our multi-gas meters and our other devices, we're seeing numbers, but we're not getting to see the chemistry that caused those numbers. So that's the nice thing in wet chemistry, is we're actually seeing it for ourselves, and we're doing the interpretation versus a device gives us information and we're doing interpretations based off that information, but we're not seeing the environment that it got those answers in. So I like the wet chemistry aspect because I see it happening and I have a little better understanding of it.
Yeah, it kind of hits you in the face, because the uncomfortable truth is we train people extensively on meters, and we barely at all on chemistry. And we've often been accused, as Derek's mentioned, old school. Well, you know what? Old school crap still works. I mean, that's the reason
Mm-hmm.
why they call it old school, right? So we got to remember some of the basics, and the basics are learning the wet chemistry. I mean, we were doing wet chemistry, one with powder calls on the tailboard of Engine 101 with the HazCat kit, and
Mm-hmm.
Bevel Aqua and I are trying to get people to stand on sides of us to do this big matrix. And again, I'm not
To
bashing the
block the
HazCat.
wind.
Yeah, and we're not bashing the kit by any means, but like Derek mentioned, so there's a learning curve. So
Mm-hmm.
just trying to do all these things, it was kind of interesting. But again, we don't train enough on it, and we rely on meters, and that's why we're talking talk about wet chemistry in this show.
Yeah, and I think that us older technicians, we the way that hazmat programs were set up, one of the classes that you took, because most of us took 4 classes,
Huh?
you took hazmat chemistry was one of your 4 classes that you took to become a technician, and you spent a lot of hands-on time doing sampling and learning to do different things, papers, seeing reactions, understanding bonding, all those things. And while we've made the transition with technology into hybrid programs and cost restraints and all those things, chemistry went from being a required part of hazmat technician to a little more optional, and rarely is there a lot of hands-on. Um, with the hybrid program, when Bob and I were first making that transition, that was the one thing that we were non-negotiable on. We're like, you can't teach chemistry online. You can
Self
present
study.
concepts. Yeah, you can present concepts online and you can talk about some of the things, but people have to actually perform wet chemistry in a hands-on manner to truly understand it, because they have to see the reaction. So unless you're mailing out uh, home kits, hey, your test just came in the mail, and we're going to all do it online together with our cameras. I mean, maybe that's an option, but really that's a classroom skill.
Yeah.
Wet chemistry is a classroom skill.
Yeah. Besides, I don't want to see somebody blow up live on their camera. That's not that you then become an
You'd rather
accessory
see it
or a
in person.
witness or something. Yeah, I want to be right there. But skill fade is real. Tool dependency is real, and institutional knowledge, it doesn't retire gracefully. It disappears.
Mhm. So at this point, you're probably like, hey, what the heck are you guys talking about? You're kind of all over the place. So Bob, we're basically building a framework here for discussion. So what's the best way we can sum this up and actually get back on track? Because I may have taken us a little off track.
Nah, you're
What are we
good.
doing?
You're good. It keeps people going while they're driving down the road. Observe, classify, test, correlate, confirm, decide. Not turn on a meter, read a number, and relax. You have to do all those things.
Yeah, and again, we're not saying that wet chemistry is replacing meters. Like Bob and I, that's our one of our bread and butters is teaching air monitoring.
Yeah.
So we would never say that. We're not gonna. We'll never say that. But what we're saying is, you have to have the wet chemistry with the air monitoring to get the full picture.
Yeah,
Because
meters give you data.
yeah, and either one, whether wet chemistry by itself is not necessarily sufficient, air monitoring by itself is not sufficient. Use the tools that are available to you to see everything and be able to actually have critical decision making.
Yeah, meters give you the data, chemistry gives you understanding, and understanding gives you safety.
Yeah, and so as we go through here, we're going to talk a little bit about when your meters are going to lie to you and when they're going to tell you the truth.
Yeah, when electronics fail short, responders still need to answer. And still need answers. And it's one of the recent ops review classes we just did. We went through the ERG book, but we did the app, and there was things that people didn't even know they could do on the app on their phone or their tablet, and they thought it was cool and faster. But electronics fail, batteries run
Mhm.
low, no service. So you still that means we got to go back to the basics, so to speak, and that's wet chemistry.
And a lot of it, when your meters fail, it usually comes down to hygiene. They've been exposed to something and you weren't aware of it, and it's caused a shift. Or it's a hygiene in how you store it, or a hygiene issue with how you calibrate it. A lot of the issues are the health of the device, and that's where you get a lot of lying. But beyond that, a lot of it comes down to the understanding. Do you know how the chemistry is affecting your multi-gas meter? And that will tell you when it's lying, when it's not lying. And at those times when it starts to do that, that's where you have to fall back to wet chemistry. And take if you haven't done so, you need to take a good wet chemistry class. I mean, we have a wet chemistry class. Our chemical hazards and sampling analysis wet chemistry class is a new one that we have for you. But whatever you take, the big thing is it needs to be repeatable, it needs to be defensible, and it needs to be a solid field chemistry approach. And the big thing is consistency. You have to be able to prove and repeat the results that you got. And if you're not doing that when you're training on wet chemistry or when you're in the field doing it, if you're not doing confirmations, then you don't know, is what I got accurate, or was it a fluke, or was there a contaminant? So, you know, um, when you're trying to classify something that you don't know what it is, meters by themselves aren't enough. Chemistry by itself is not enough. You have to bring those two together to get that full picture.
And I encourage everybody, if you have, I've seen it on first arriving units now. Even some of them are have a 4 gas meter and pH paper. And that's great. And everybody's, pH paper, it's either red or blue. Well, there's a lot of things to keep to pH paper that you've got to learn. But whether you're the ops level person or the hazmat tech, get your papers out and in a controlled environment, because we want to be safe, right? Practice with them.
Hmm.
We practice and train on EMS calls and how to pull a hose. People are pulling hose and throwing ladders all the time. Well, that's great, but those are calls that you run all the time. You should be practicing training more on the things that are less frequent. And just
You
remember what's that?
you said moron.
When you train on those things that you don't run as frequently, that's where you start having problems. So you should be training
Yeah.
more on those items and not try to figure it out at 3 o'clock in the morning. So, um,
Yeah.
but
And Bob, I know that I made a shameless plug for our wet chemistry class because
ah,
I'm proud of what we've accomplished, and
yes.
if people wanted to look deeper into that, um, where would they find information about that?
Well, Derek, right after they like and subscribe this episode on YouTube, which by the way, this one is there's no pictures, there's no video, so you can listen to it on your way in or out of the fire station. We try to mix up the episodes a little bit. But after you like and subscribe on YouTube, you can go to hazmat101consultants.com or Bob at hazmat101consultants.com and get some more information on any of our wonderful classes. So, any last words? I always say that, and I feel so bad when I say any last words. Like, last words before I put you in an electric chair.
What's my final meal?
let me get to social media real quick. So please make sure you follow us on Facebook, and as I mentioned, we're on all the platforms. We do have shows that have video and pictures, so you'd want to watch those on our YouTube channel. Again, don't forget to like and subscribe. My book came out. It's been selling off the shelves. I'm really happy. Thank you for everybody who's purchased one. You helped me buy a cigar or a golf ball. No, I'm just kidding. We roll right back into our teachings because we want to help other people out. And then some websites that you guys can follow is, the HazMat Guys Roundtable, the first Tuesday of every month. We do a live show. Myself, Bobby Salveson, Mike Monaco, and Jeff Ziontek, live 8 p.m. Eastern. Check it out. HazMat Group, Common Sense, and the other HazMat Facebook pages. Great sources are great places for resource and information. You can get a lot of stuff. People are glad to help you out. So now, any last words?
No, I think like Bob said, please like and subscribe. Our ultimate goal is not only education but also world domination. So the more followers and subscribers we get, the more that we can be. We want one of those YouTube award plaques that we can put in the background. Yeah. So help us get there. You know what? I bet you guys can't get us there.
There you go.
Prove us wrong.
And before
we'll just make our own. We know a trophy guy. We'll make our own.
We know a guy. And before we leave, we forgot to mention we did the Florida HazMat Symposium a few weeks back. It was great. Good seeing old friends, meeting new ones. And if you haven't checked that one out, that's usually around the third week of January-ish. So be sure to be on the lookout for that. And also, we want to hear from you guys. You got a run that you ran, some type of incident or questions. Shoot me an email, Bob at hazmat101consultants.com. So if you don't want to mention your department or whatever, that's fine. We can change it up so nobody knows who you are, and you'll be in complete witness protection. But we want to hear from you guys because, because sharing is caring. And, what do we always say, Derek?
When you're through, you're through.
That's it. When you're through learning, you're through, baby. All right. That's enough of us two. We'll see you guys later. I'm going to go drink some more coffee so I'm not messing up my words. Good God. Peace out.
Have a great 2026, everybody.
Stay safe.